Hello everybody, welcome to this episode on statistics. In this video, we will be talking about hypothesis testing. To understand what hypothesis testing means, we have to know what claims are. Claims are something that we hear every day. A claim could be that video games increase stress. That's a claim. And hypothesis test is a statistical procedure designed to test the claim. So with the hypothesis test, I can either I can either deny this claim, I can say that no, this claim is wrong, or I can say that yes, this claim is right. That's what I do with the hypothesis test, and there are certain steps to it. And you're seeing all of the steps on the screen right now. We are going to be going through all of these steps in this video step by step. It's not as hard as it looks. Let's start with setting up a null and alternative hypothesis. So in every hypothesis test, there are always two set of statements that oppose each other. One is the null hypothesis and the other is the alternative hypothesis. The null hypothesis is written as H and a 0 on the bottom right corner. An alternative hypothesis is written as H and the same format, H and A. The null hypothesis is basically agrees with the claim. It says that yes, the claim is correct. Let's say that the claim is that a certain medicine decreases blood pressure by 10 units. That this medicine on average decreases blood pressure by 10 units. Then the null hypothesis will look something like this. H0, that's the null hypothesis. A stands for average, and 10 is 10 units. So this medicine decreases blood pressure by an average of 10 units. And the alternative hypothesis, it basically disagrees with it. So it says that no, it's not true. And there are three ways to disagree with the null hypothesis. Firstly, you can say that no, A is smaller than 10. You could say that A is bigger than 10. Or you could say that A is not equal to 10. So it's either smaller or bigger. Okay, now that we've talked about setting up a null and alternative hypothesis, let's talk about collecting good data and using a well-designed study. Do you have enough data to do that? And that is a question that you might have. Of course, there are ways to get more accurate results, and that is with a random sample and a large sample. The more larger and the more random your sample is, the more accurate the data will be. But there are actually two different ways to collect the data. That is with surveys and experiments. These are two ways to collect the data for hypothesis testing. And these two are beyond the scope of this video because it will take too long to put both of them in one video. I'm going to make two different videos on surveys and experiments later on this channel. So let's skip this one part for now. Let's talk about calculating the test statistic based on the data that you've collected. So let's say that you've already collected that data, whether it's using a survey or an experiment, and you've already got the statistic that you want. Let's say it's an average. Now we have to find out the test statistic. The test statistic tells us how many standard errors or z-values the null hypothesis is away from the statistic that you have. It sounds a bit complicated, but we've already gone through this once in the channel. It's not that hard. It's a bit different for hypothesis tests. So I'm gonna show you guys the formula again. First, you have to get your statistic. That's your statistic. Let's say it's an average of 100 or whatever, minus the null hypothesis. That's the claimed average, divided by the standard error. If you do not know what standard error is, go check out the video in the description. I already explained what standard error is clearly. But there's one thing you have to take note of. This is the formula for test statistic, but there's one thing you have to take note of. If your alternative hypothesis is average is less than 1,000, for example, 1,000 is an example. Let's say it's less than, then you have to use this formula. But if it's more than, you have to use the same formula, but you have to do 1 minus this formula. That's just one thing to take note of. So let's say that you've gotten this as a result. Minus 1.96. The further away the test statistic is from 0, the more evidence you have against the null hypothesis. So if you have -3 or +3, that means you have a lot of evidence against the null hypothesis. If you have -0.2 or +0.2, that means you have very less evidence against the null hypothesis. So the bigger the number, the further the number away is from 0, the higher chance you have of rejecting, of saying that the null hypothesis is wrong, the claim is wrong. So the bigger the number, the higher chance you have of seeing that it's wrong, or more evidence you have, basically. Now we've talked about calculating the test statistic based on your data. That was the test statistic. Now let's talk about finding the p-value for your test statistic. So what are p-values? I'll explain it with this example. Let's say that this is a sample, and the average height of the sample is 5 feet 7. This is another sample. What is the chance? What is the chance that the average height of this sample is 5 feet 7 too? The chance is probably not very high, because the average of different samples are usually not the same. It could be 6v2. We do not know that. So that's why it's always good to you must calculate the p-value, basically. And how do you calculate it? The p-value basically shows that the probability basically tells us the probability of the test statistic occurring in this next sample. So if you have one sample and you got your test statistic, what is the probability that you have the same test statistic for another sample? That's what the p-value tells us. So the p-value of the test statistic, there are two different ways of calculating it, and that is with a z-table or t-table. And of course, we've talked about z and t-tables on the channel. You use a t-table when your sample is below 30, the size of the sample is below 30, or when you do not know the population standard deviation. But you use the z-table at any other time you use the z-table. It's been quite a while since I talked about z-tables, so just for this video, I'm going to show you how the z-table works again. So this is the z-table. Let's say that this is your test statistic. How do you calculate the p-value? First divide this number into two different parts. Let's break it into half. Minus 1.9 and 0.06. So think of this as minus 1.9 and think of this as 0.06. So now we have to look for minus 1.9 somewhere over here. And there you go, I found it. It's here, right here, minus 1.9. Now we have to look for 0.06, and there you go, there it is. We found both of them, and now we just have to intersect. Now that we intersect, we find that the p-value is 0.0250. That's how you find the p-value of your test statistic. Now you have to decide whether or not to reject your null hypothesis based on your p-value that you've got. So what that basically means is saying, do you have enough data to say that the null hypothesis is wrong, or do you not have enough data? It's either that you have a lot of data, your p-value is big enough, and you can say, no, this null hypothesis is wrong, the claim is wrong, or you say the claim is right because we do not have enough data. One thing you have to keep in mind is that the claim, which is the null hypothesis, it's always right. It's always right until you prove it wrong. And how do we do this? We do this through a predetermined cutoff point. Before you start anything, before you start any of the steps that I mentioned in hypothesis testing, you have to choose a significance level, which is basically either 0.01, 0.05, or 0.1. These are the most popular ones. And you have to choose. So if you choose 0.05, which is the most popular one, it's basically like saying if your p-value is smaller than 0.05, then you can have the ability, you have enough data to reject the null hypothesis. But note, if you do this at the end, don't do this at the end, always at the start, otherwise it wouldn't make sense. Otherwise I would have a p-value of 0.5, which is not enough evidence at all, and I could just say that the significance level is 0.6, then I basically reject it. But that doesn't get us anything. That doesn't actually show us anything. We have to choose the significance level at the start. And only if the p-value is less than or equal to the significance level can you reject the null hypothesis. Of course, another thing to note is that you have to consider what is marginal. You call it marginal when, let's say that this is your p-value 0.049 and this is the significance of 0.05. So they're very similar. It's basically 0.001 lower. You can technically reject it, but usually it's better to say that it's marginal and not do anything about it. So you do not have enough evidence. You do not have enough evidence to reject it, but you also have enough evidence to say that it might not be true. So you do not do anything in this case. When it's marginal, you do not do anything. So that's how that's how to decide whether you have enough data or not. Now, understanding that your conclusions may go wrong. There are two types of errors that might occur. There are two types of errors: type 1 error and type 2 error. Type 1 error is when you've collected a sample correctly, you've collected it randomly, you've conducted the experiment or survey correctly, you've found out the p-value, you've chosen the significance out of the shot, you've done everything right, and you've proved the null hypothesis wrong, even though it was actually correct. And type 2 error is when you did everything right like before, but you couldn't prove it wrong. Even though you couldn't prove it wrong, even though the null hypothesis was actually wrong. These are two different type of errors, and we cannot actually do anything about it. The best way to avoid these errors is, of course, collecting a bigger sample. But the bigger the sample you collect, the closer you're going to get to the population. And there is always a chance. You can never 100% be sure unless you collect the whole population. But then if you collect the whole population, then there's no point. There's no point of hypothesis testing if you have the ability to. So these, sometimes you might um, uh, you might find yourself with a type 1 or type 2 error, but we cannot really do anything about it. Okay guys, that's it for this video. To end off, to ease your eyes, here's a rainbow hypothesis test steps. The steps to find the hypothesis, the steps to testing your. Okay guys, that's it for this video. To end off, I'm gonna show you guys a rainbow. I'm gonna show you guys. Okay guys, that's it for this video. To end off, let's ease all of our eyes with this rainbow right here. It's a hypothesis test rainbow. It shows all of the steps again in the colors of the rainbow. I hope that you've all learned something from this video. If you have, don't hesitate. If you have any questions, don't hesitate to put it down in the comments. If you like the video, why don't you go ahead and leave a like. If you want to watch more videos like this, subscribe or check my playlist on statistics. See you all in the next one.